All right, this is Honors Algebra 2 Pre-Calc. We're doing 4.2 in Algebra 2, which is matrix multiplication. And for this last video, we're just going to do some extra practice at matrix multiplication by hand, just because it's good for us to get some extra practice in at this. So we're going to do an E4 and a P4 that just gives us a little extra practice. And you can put this in your calculator to check as well, but we're going to walk through it by hand first, right? So if you want to kind of be lazy about it, we could totally just take little shots of these and then put them in order because I'm feeling lazy and don't feel like writing them. So A times B is going to look like this, A times B, right? And B times A is going to look like this, B times A, right? Okay, cool. So now we can be kind of lazy about it and not have to do everything by hand. Okay, so first thing you want to do is figure out if the multiplication works, and if it does work, then you want to figure out the answer, and if it doesn't work, then you can just say it doesn't work. All right, so there are 3 rows here by 2 columns, and this has 2 rows by 3 columns. So not only does it work, right, the inner dimensions are the same, but my final answer is going to be a 3 by 3, right? So when I make my big giant work matrix, if I'm doing this by hand, I need some space. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's kind of lopsided, but you get the idea. All right. So I get that my answer is going to be a 3 by 3 matrix, right? So let's go ahead and get through this one first, and then we'll go from there. All right. So for the entirety of this top row, I'm going to use row 1, right? I'm just going to use this row 1, and I'm going to multiply it by each of the subsequent columns, right? So for this first spot, I'm going to do row 1 times column 1. Well, that's going to be 4 times 4 plus, and then I multiply the corresponding entries, 5 times 0, right? And if you want, you can squeeze this in at the end and try to squeeze in your answer. I'm going to put the answer probably, you know what we're going to do? We're going to just erase after we do A, B, and then we'll give ourselves some space. So my answer is going to end up looking like this. And you don't have to do this with the blank spaces, but it's a nice way to make sure you're paying attention that you didn't miss anything, right? It's going to end up being a 16 plus a 0, which is just a 16, right? For the next one, I'm still going to take my row 1, but now I'm going to take column 2, right? So that's going to be 4 times 2, right? So 4 times 2 plus 5 times 1, right? So that's an 8 plus a 5, which is a 13. And then for the last one, I'm still going to use row 1, but now I'm going to use column 3. So it's going to be 4 times the negative 1 plus a 5 times the 3. So that's a negative 4 and a 15, which I'm pretty sure comes out to an 11. And once I've done that, I'm now done with row 1, right? I did the entire row 1. I've finished row 1. So now I'm going to look at row 2, and I'm going to do the same thing with the 3 columns, right? I'm going to do row 2 times column 1, so that's going to be negative 2 times 4 plus 1 times 0, which seems to be a negative 8, right? I'm going to do row 2 times column 2, which is going to be negative 2 times 2 plus a 1 times a 1. Well, that's a negative 4 and a plus 1, so that's a negative 3, right? And then, I don't know, we'll try with the yellow. Negative 2 and 1, and then times the negative 1 and 3. So that's going to be negative 2 times the negative 1 plus the 1 times the 3. And I ran out of space, so I cheated. So that should be a positive 2 and a positive 3, which is going to be a 5, right? So then if we loop back to the beginning, right now I'm done with my second row. The whole second row is done. So now I'm going to use my third row, which is 3, 0, and do the same thing. So this is going to be 3 times the 4 plus the 0 times the 0, so I get a 12, right? For the next one, it's going to be the 3 and the 0 and the 2 and the 1, right? So that's going to be the 3 times the 2 plus the 0 times the 1, so that's a 6, right? And then for the last one, it's going to be the 3 and the 0 times the negative 1 and the 3, so the 3 times the negative 1, right? Plus the 0 times the 3, right? So I end up getting a negative 3, right? And so that's my 3 by 3 answer. Now, it certainly doesn't hurt to check, especially when you're doing a long matrix multiplication problem like this. Like if it were me, I might go ahead, if I'm multiplying matrices, and edit my A to be a 3 by 2 that looks like this: 4, 5, negative 2, 1, 3, 0, and then I would double check that it lines up. 4, 5, negative 2, 1, 3, 0, perfect. I'd quit out and do the same thing for my B, right? So second matrix, go over to edit and pick B, and B is going to be a 2 by 3. So that's going to be 4, 2, -1, 0, 1, and 3, and then I double check that everything's right before I move on. It looks right, and then there's no reason I can't just go ahead and now do my second matrix A, second matrix. And the reason I say it doesn't hurt to do this is because no matter how good you get at math, sometimes you add wrong or you multiply wrong or you just write something wrong. So let's see if it turned out right, and if it didn't, we'll figure out what went wrong. So 16, 13, 11, -8, -3, 5, 12, 6, -3. Sweet, we did it right, which is super exciting. So again, it doesn't hurt to type in your calculator, especially with the multiplication, because then you know if you did something crazy. So let's go ahead and we'll erase this stuff, and we're going to go ahead and do B times A, right? So B times A is going to have a really different answer. Hang on, inadvertently made a window much smaller. All right, so B times A is going to have a different answer because instead of being a 3 by 2 and a 2 by 3, it's the reverse order. So my answer is going to look like some different dimensions, right? So this is a 2 by 3 times a 3 by 2. So it does work. Yet again, we have one where it's okay, the inner dimensions match, but my answer is going to be a 2 by 2. So what that means is if we put our work matrix up here, and I'm going to go ahead and cross that out because we're not using this one now, it's 2 by 2, but because it's only 2 by 2, what you're going to find is you're going to need more space for this because you're going to be multiplying and adding 3 corresponding terms, right? So I'm going to use this first row for the entire first row of my resulting matrix, right? So I'm going to use that first row for the whole top row. So first I'm going to do the first row times the first column. Well, that means I do the corresponding parts, right? So the 4 is going to go with the 4, the 2 goes with the -2, the -1 goes with the 3. So I'm going to get 4 times 4, right? And if you want, you can just do 16. So 4 times 4, I'm going to get 2 times a -2, so that's a -4. And I'm going to get 3 times a -1, which is a -3, so I'm pretty sure I get a 9, right? And if you need to write it like this, if you need the 4 times the 4 plus the 2 times the -2 plus the -1 times the 3, that's great, totally fine. If you don't need that, also totally fine. Then I'm going to do the same thing with this same first row, but times the next column. So it's going to be 4 times the 5, which gives me a 20, right? 2 times the 1, which gives me a +2, and a -1 times the 0, which gives me a 0, so I'm pretty sure I get a 22 there. The next one, I'm now done with row 1, and I'm going to start with row 2, which is the 0, 1, 3. So it's going to be row 2 times the first column. Well, that's going to be 0 times the 4, so that's a 0, plus the 1 times the -2, so that's a -2, plus the 3 times the 3, which is a 9, so I'm pretty sure that lands me with a 7. And if I do the last one, again, I'm still taking that second row, but now I'm using the 5, 1, 0. So 0 times the 5 is a 0, plus 1 times the 1 gives me a 1, plus 3 times the 0 gives me a 0, and I think I get a 1. And we can verify that in our calculator. It's up to you. You could just hit second enter and then delete part of it, or honestly, it's about the same number of button presses to just go ahead and get B times A, right? So second matrix and 1 and hit enter. And we get a 9, 22, 7, 1. We win, right? So that's the idea. It's definitely not a bad thing to put in your calculator just because you're going to add wrong at least once, says the person who is actually genuinely paid to do math and totally adds wrong pretty regularly. So again, I'm kind of lazy, so I'm going to screenshot these instead of copying them, and I'm sorry to those of you doing these problems in your notes that you don't have that luxury. So here's A times B, right? And then B times A. And this is basically the same idea, the same trick, right? I want you to see that, that the order that you do this is going to get you a different answer, right? So go ahead and give it a try if you want. You can pause me and try it on your own, right? So like I said, same with the last one, I'm probably going to have to do the first one and then erase the answer so I have room to do the second one. So this is 2 rows by 3 columns, and this is 3 rows by 2 columns. So yes, it's okay. And my answer is going to be a 2 by 2. So basically, I gave you these in the reverse order of the way we did them in E4, right? So my answer is going to be a 2 by 2. I know ahead of time that I need a lot of space for that 2 by 2, right? And honestly, you can probably squeeze the 2 by 2 one in pretty small because 2 by 2s are obviously smaller than 3 by 3s. All right, so first row is going to get used for the entire first row of this answer, right? So first row times first column is going to be the 5 times the 8, which is a 40, plus the negative 3 times the 0, which is a 0, plus the 1 times the 2, which is a 2, so I get 42, right? First row, second column is going to be 5 times the 1, which is a 5, plus negative 3 times the 4, which is a negative 12, plus 1 times the 5, which is a 5. I think I get 10 and negative 12, which is a negative 2. And then for my second row, right, so the entire second row of the resulting matrix, I'm going to use the second row of the first matrix. So second row times the first column is going to be negative 2 times 8, which is a negative 16, negative 1 times 0, which is a 0, and 4 times 2, which is an 8, right? So that should be a negative 8. All right. And then for the last one, right, so second row, second column, negative 2 times 1 is a negative 2. Negative 1 times positive 4 is a negative 4, right? And 4 times 5 is a 20, so I think I get a negative 6 and a 20, which should come out as a 14. Right, we can double check that, right? When you go to do that, you're going to go to your second matrix, right? So second matrix, you're going to edit, right? And this time my A is the 2 by 3, right? And it's a 5, negative 3, 1, negative 2, negative 1, 4, and then you should always double check because that's really where most of the mistakes happen, is that you don't double check they line up. And then I quit out, so second mode gives me quit. I go back to matrix, right? I'm going to pick, go over to edit and pick B this time, and now B is the 3 by 2, and it's an 8, oh, sorry, ignore the plus, 1, 0, 4, 2, and 5, right? All right, so double check that it's right. I quit out. And I wanted to do, now I could be kind of lazy and do second enter twice, because I know that I had an A times B two terms up, right? This thing was an A times B. So second enter gives you the last entry. If you repeatedly do that in a row, you'll get the entries, you'll keep going back. I get 42, negative 2, negative 8, 14, sweet. All right, cool. So I'm going to go ahead and erase this one so we have some space for the next one, because it's also going to require a decent amount of space. Right, the next one's going to be our 3 by 3 answer by the same logic that we saw in E4. So this is 3 rows by 2 columns, and this is 2 rows by 3 columns. So yes, it's totally okay to do this, and my answer is going to be a 3 by 3. So let's give ourselves a good amount of space. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then that'll give me a nice little answer matrix that I can just write the numbers in, right? You don't have to do this, but it's a really easy way to keep your work organized. Okay, so we know that for the whole first row, I'm using the first row of the first matrix, and then I'm going to multiply it by each of these columns in turn. So 8 times the 5 gives me a 40. 1 times the negative 2 gives me a negative 2, so this should be a 38. 8 times the negative 3 gives me a negative 24. 1 times the negative 1 gives me a negative 1, so that should be a negative 25. 8 times the 1 gives me an 8, plus 1 times the 4 gives me a 4, so that should be a 12. All right, so now I'm done with the first row, and I'm going to go ahead and use the second row. So it's a 0, 4. Honestly, you can be a little lazy here. Because there's a 0, all of these top numbers are going to get wiped out. Like 0 times 5 is just going to be a 0. So really what you're looking at is this 4 times whatever the bottom number is, right? Because this is going to be a 0 minus an 8, which is a negative 8, right? The next one's going to be 0 times the negative 3, which is a 0, and then the 4 times the negative 1, which is a negative 4. And then the last one's going to be 0 times the 1, which again totally wipes that out, and then 4 times the 4, which is 16. All right, so now we're on to our very last row, which is a 2 and a 5. So 2 times 5 gives me 10. 5 times negative 2 gives me negative 10, so that's a 0. Right? 2 times negative 3 is a negative 6. 5 times negative 1 is a negative 5, so that's a negative 11. And 2 times 1 is a 2. 5 times 4 is a 20. Sometimes your brain wanders, and so that should give me a 22. So I'm going to go ahead and check it, right? So I'm going to hit second enter, and I'm going to do it twice because I just want B times A. Oops, sorry. Second enter gives me the last one, and then I do it again, and I get that one. Okay. 38, negative 25, 12, negative 8, negative 4, 16, 0, negative 11, 22, so we are right. So again, if it were me and I had time on an assessment, I would probably put this in my calculator as a backup. Even if I ask you to show work, the work can look like this, right? The work can't just be the work cannot just be here, right? The work can be this, the work can go back to the one where I showed you this kind of work, right? That's fine. But if I'm asking you to show that you know how to do this by hand, the only way to verify that you know how to do it by hand is to actually straight up do it in some way. And if you just jump here, I don't know that you didn't just type it in a calculator and copy the numbers. Again, part of this is learning how to apply an algorithm. You're not going to have to do matrix multiplication by hand a lot in your entire life, I promise. But part of this is learning to follow a pattern and how to apply it. And part of that is learning how to do it under the pressure of an assessment, which is an important skill. Being able to perform under pressure is a skill that matters in life, even if we hate it. All right, that's it for this section and this video.